people logging in, but we are at the 10 o'clock hour, and to keep your guys' busy days going, we'll get started. I do appreciate you taking the time out of your busy schedules to sign up and participate in today's session. I think today's session is a very interesting topic. No Fines Concrete is fairly new to North America. We're probably 5 to maybe 8 years. The first time it was really introduced in segmental retaining walls. It's been in Australia. The first time we ever heard about it was 25 years ago. And they've been using it extensively then, and they still use it today, possibly even more so than GeoGrid, actually, in there. So with that, let's get started. And so this is a basic block that we made for some presentations that we had. We also used similar blocks for some testing we did. As you can see, water runs right through it. I like to refer to our No Fines Concrete as basically the Gray Rice Krispie bar. So today, really what I'm going to try to talk to you about is that new tool that is in your toolbox, and that tool is the No Fines Concrete. It is a great solution for many things on a job site. It's not the be-all and end-all. It can't fix everything, but it can be done and used very efficiently in many, many circumstances. So one of the main things is tight constraints. So a GeoGrid reinforced segmental wall is generally speaking going to be 60 to 70% of the total wall height. In virtually all situations, a No Fines Concrete is going to be lower, somewhere between 30, 40, maybe 50%, depending upon what's above. But that can be quite a bit of savings when you talk about excavation, property line constraints, utilities. If the utilities are in the ground and we have to excavate close to them, No Fines Concrete can be used to pour up against them or encapsulate them, and again, great solution. Existing conditions such as bedrock. So we have many situations where we've been asked to put an alum block facing in front of a wall, or a rock face that maybe has some water bleeding out of it over time, but it's shaling away, it's getting weathered. So building an alum block wall in front of it and filling the irregular void between the rock and the back of the facing with No Fines is a great solution there. And the No Fines being so porous allows any water that might migrate through the rock to run right through it, down to the drain and out the wall. Poor soils. Lots of projects out there have poor soils. Some are worse than others, but we've seen No Fines Concrete used by local engineers to span over very poor soils where differential settlement concerns are there. That's a great option there. And then big blocks. So big blocks is kind of a slang term we use for the big wet cast blocks. So wet cast blocks used to be really just made from the excess concrete that would come back from the job sites in a concrete truck with very simple formwork. Those large blocks might be used for creating bin walls at their sites, at the ready-mix sites. But obviously today, big blocks are a market upon themselves. But the idea that big blocks can be used in certain situations and alum block walls can't be is really a misnomer. Alum block and No Fines Concrete does basically the exact same thing as a big block, because the No Fines mass added to the alum block facing is pretty much the same footprint as a big block. So we're going to talk a lot about big blocks at the end. So let's talk about some engineering properties. So No Fines Concrete is very similar to pervious concrete, but it uses larger aggregate. So typically you're going to use a 3/4 inch rock, whereas pervious concrete is probably more like a 3/8 inch pea gravel. But it also is a lot more porous than pervious concrete. The density of the material, it's going to come in right around 100 to 130 pounds per cubic foot, depending upon the rock, the weight of the rock in your area. And water content ratio is somewhere around 45 to 55%. So we don't want to overwater it, because that just breaks down the cement, but underwater doesn't activate the cement. So, and like I said, about 3/4 inch rock is the most common used. No fines concrete has a very similar slump to wet aggregate. When I first started looking at no fines, I'm thinking probably a zero slump product. But really, when we started looking at it, all it is a wet rock when the cement is not cured. So it does have some pressure that's exerted on the block facing, or I should say the back of the block. So don't think about no fines as a zero slump product. It's got a little bit of slump, but as soon as it cures, it's completely solid. So the cured concrete strength generally comes in about the 900 to 1400 psi, but we certainly don't want to promote the idea that compressive strength or a certain level of compressive strength is needed, because it's just backfill. Similar to some flowable fills out there, very low compressive strength. No fines concrete does not have to be a high compressive strength, like say a flat work concrete mix being 3,000 to 4,000 psi. Don't need that. We mixed our first batches just simply in a wheelbarrow, and we took some cones and had them tested just to understand it, and they very easily came into that 900 to 1,400 pound range. So, and the void ratio is around 20 to 30%. Can be larger if you're using larger aggregate in some situations. So here's a typical cross section of a GeoGrid reinforced wall out of our AB wall software. So in this case, we've got a 4-to-1 slope above, continuous, 7.5 feet. It's about a 12-foot high wall. So your property line could be back there at that 7.5-foot mark. Well, if you have site constraints, a no fines concrete wall, the exact same conditions, can be about 5 feet. Now, I don't know exactly what soils we used when we ran these sections, but a 2.5-foot savings in excavation can really be a job saver in a lot of tight sites. So no fines concrete can go virtually any height, but generally you're talking about the 12-foot high range of wall heights. So here's another cross-section out of AB walls using no fines concrete. This comes out of our complex composite section in our program. Complex composite structures is a very unique feature to a segmental wall program. We developed it a few years back. It allows you to do basically two structures. The lower structure, in this case, you're seeing a no fine structure at the bottom with a shallow depth, and then a GeoGrid reinforced wall above. Well, the complex composite functions inside of the AB walls allows you to have shorter grid lengths at the bottom, longer grid lengths at the top, or vice versa. Deeper no fines at the bottom, shorter no fines at the top. So it's giving you yet another tool in that toolbox to solve those complex issues that might come up on site. This particular section is probably most common to think that there's some utilities behind the no fines mass that we can't excavate into. The complex composite structure section is covered under our advanced tutorial. So I welcome all of you to, if you have AB walls, you want a refresher tutorial. If you don't have AB walls, we're glad to give you a tutorial. But we will start with what we call the basic tutorial. It's going to talk to you about the functionality of the program. The advanced tutorial is cover complex composite structures and many other complex, or should I say, advanced features in our program. So, and both of those 1 hour times are available for continuing education credits, and we welcome you to reach out to us and set up a time to do that. So let's talk about design parameters. So those of you that are familiar with segmental wall designs, we have a GeoGrid reinforced design format, and we have a gravity wall format. So no fines concrete basically fits into that gravity wall format, because the definition of a gravity wall is a wall under its own weight is resisting the surcharges and the forces from behind. So no fines concrete simply increases the depth of the facing. By doing that, you're increasing the eccentricity of the mass and the weight of the mass, and again, gravity functions come into play. You're resisting sliding and you're resisting overturning. Like I said earlier, typically you're looking at 30, 35, 45% for the total depth relative to the height. The one exception is when you have steep slopes above the wall. So because the no fines concrete generally is lighter than a geogrid reinforced wall, and slopes above the wall tend to exert a lot of force on the back of a wall, your mass starts to increase because of sliding restraints. So in that one instance, no fines concrete is pretty similar to geogrid, but in almost every other circumstance that I can think of, your structure depth is going to be much less. So the less excavation saves time and thus saves project cost to the owner of the project as well, because you're not excavating as much or refilling as much. 2 course pour is what we recommend. So dry stack 2 courses, maybe 3, but generally speaking about 2 course spacing, 2 course dry stack. And then when you're placing the material behind the wall, you're simply shoveling down into the cores and rodding it into the course to try to fill that bottom course and that second course up nice and tight with the no fines. If you do 3, it's harder to get the material down into that first core. If you do 4, it's very difficult. So that's why we really recommend the 2 course, and that's really the best way to go. The next 2 courses, so imagine you're building it from left to right. You're stacking your block, you're filling the cores, you're filling behind the wall, rodding the cores. By the time you get to the end of your 2 courses, you can come right back to the beginning and set your next 2 courses. It takes about 2 to 3 hours for the material to start setting up, but it's a fairly continuous construction process throughout the day. The friction angle of the material is, in AB walls, we use 75 degrees. We had some independent testing done at Braun Intertech here in Minneapolis. They kind of first looked at me a little cross-eyed when I came and asked them to do a direct shear test on no fines concrete. They said, well, hey, it's concrete. It should be like 90% friction angle. And I said, well, we want to use this in the segmental retaining wall design software, and we use friction angle to talk about the strength of soil. So let's just run some tests and figure out what a really good usable value for it is. And they were quite surprised when they came in at about 78 or 9%, degrees. So we take a little bit less than that. We just say 75 degrees is our friction angle for no fines concrete. And that allows us to then use the Coulomb equations and so forth inside of the geogrid reinforced design methodologies. Again, there's no compaction needed, so that saves time. There's no wall rock that needs to be put in the cores because you're just using the no fines, so you don't have the extra piles of the various rock on site. And we also have a masonry fence product, and many times we're being asked to retain soil with that fence product as well. We do use geogrid and normal geogrid construction, but in some cases, no fines concrete is really the way to go with it as well. So let's talk a little bit about a mixed design. Now, I'm not a mixed design expert. Many of you might be, but this is just really to represent the idea that no fines is very simple. We're talking cement, stone, and water. The permeable mixes are going to have the admixtures and so forth that might make it even stronger. You're not looking for that. This weight ratio gives you a little over 4-to-1 ratio. Typically, we're going to see the 4-to-1 to 5-to-1 ratio between stone and cement, and about a 30% water to cement ratio. So very simple. And again, in the early days of no fines, most of the walls were material was mixed right on site. And even today, it's very simple to do that. But some of the ready mixes around the areas are becoming much more familiar with it, so it's much easier to get than it was in the beginning days. Okay, so let's switch over and talk about construction. So, like I said, about 25 years ago, no fines concrete was used extensively in Australia, and because we have a very large presence in Australia, we obviously were used a lot with it, so we got to know it quite well. The picture on the right shows a great installation happening. They've got 3 courses stacked, but what I like about this picture is I'm able to show you guys one of the key things that we really promote is knocking the wings off of the back of the block, even in straight walls. So typically in straight walls we would leave them on because it helps the installer make the wall nice and straight. But if you knock the wings off, it allows the material to flow into that triangular space between the 2 webs, and it makes a nice connection to the mass. And you'll see the gentleman in the blue hat back, he's shoveling material into that area and down into the cores. And then also you can see in the lower part here, there is a drain pipe. And we definitely want to promote the idea of drainage because the water is going to flow right through this, and we want to get it to that drain pipe and exit it to daylight or to an underground drainage system. Now these guys are really happy because this particular wall has access for a truck to drive right alongside it. That's not the most common thing you're going to see, but again, it's a great picture to talk about the installation of it. So this is the first project that we're aware of in the United States. It was an alum block project here in one of the suburbs of Minneapolis, and it's a very interesting project. There was deteriorating railroad ties placed in and needing to be removed. It's a triangular shaped window for a local architect, and so a very unique situation with that acute angle there. And we mixed all this on site, and was a great solution for this first project using no fines. By far, this is the most common way you see no fines today. You're picking it up out of the chute into the Bobcat bucket, and you're bringing the skid loader around and dropping it in the wall. A complete set of installation steps are in our commercial install manual, and that will be one of the links that I will include in the follow-up email I'll be sending you guys. So, but here's the basics. You're moving the stuff around with a shovel, right? There's no compaction needed, so the guys really love it because they don't have to bring the compactor on site. They're shoveling it into the cores, and they're rodding it down to make sure that you're getting nice coverage down into those lower cores. And probably one of the most important things is don't forget to sweep off the top. So if those little pebbles get cured to the top of the alum block, you're coming along and having to chisel them off as opposed to when you're sweeping them off when they're still wet. Those pebbles will really disrupt the placement of that next course. So make sure the material is nice and clean and ready for the next courses. So here's a creative solution that one of our installers used on a project. The person that came in and did the excavation over-excavated the site, and the idea of filling up that over-excavated area with no fines was a deterrent to this contractor because he didn't want to buy that material. So he came up with very simple form work, and you can see in this picture that he's actually cut some handles in there for his guys to be able to grab it and shake it loose and pull it out when it's done. But the design required only a certain depth, and it looks to me about 3, maybe 3.5 foot of wall depth. And then behind, he assured me they were putting a rock and compactable material behind there. But that's one thing to think about. If you over compact and you're using a no fines wall, you might not want to spend the extra money to buy all that material to fill in the void. So excavation is important to think about, but here's was a creative solution to take care of that over excavation. So very simple assembly line really is what you're looking at. You're looking at 2 to 3 course stack block. You're talking about one guy driving the skid steer. You're talking about one person shoveling, person rodding the material, and a person making sure to clean it up. So, with a 4-person crew, you're assembling this wall quite quickly. But if you double up on jobs, maybe you only have a 3-person crew. But anyways, the point is the material goes in so quickly. And I would be hard-pressed to find a contractor out there that has used it that doesn't want to use it again. Once they have used it, they feel, wow, this is great stuff. It's really easy to use. They keep looking for other opportunities to use no fines concrete along with the Allen block facing. So, and the last thing I'll leave you, I touched on it earlier, is the cost of no fines should be much less than your concrete mix or your permeable mix because it's so simple. That's one of the points I'll mention when we talk about the ready mix plants. They might want to charge you too much, so be careful with that when you start getting into it. So here's a very basic cross section. It happens to show a no fines mass at the bottom and then 3 courses of dry stack at the top. This might be a perfect opportunity to talk about fences above the wall. So no fines concrete certainly can go all the way to the top, or maybe the top 12 inches is topsoil. But if you're going to put a fence in, you really need to coordinate the fence installers with the wall installers, because you can put a construction tube in as they're building the wall at the appropriate post spacings. That way we don't have that angry phone call when the fence installer is coming and he's trying to auger into the no fines concrete and it's not working. But this particular would be application or cross section would be perfect for maybe a sleeve-it product from the Strata system. They're typically about 3 courses behind the wall that work perfectly. Okay, so let's talk about the big blocks. So again, big blocks are wet cast blocks. Their big marketing idea is bigger is better. Well, they can't compete when it comes to cost. We can send so much more square footage out on a truck with an Allen block wall than on a big block wall. The big blocks just weigh so much all by themselves that you have to make multiple truck trips. And if any of you are involved in pricing projects, truck trips are not cheap. All right, so they really add to the cost of the project. They need larger equipment. Allen block, you know how easy it is. It's 75 pounds for a large block, very easy to move around. The equipment you need for a big block is going to eliminate some installers from putting it in. Big blocks are also very hard to work when it comes to curves. They are typically made rectangular, and in order to do outside curves, they need to be saw cut. Very difficult to saw cut. Allen block can do serpentine walls, outside radius, inside radius is very simply. I'm sure most of you have seen them installed. And adding the no fines concrete to them creates them exactly the same depth as a large block. The weight, the mass of the no fines concrete is going to do exactly the same as the big block at a much cheaper price. If there's discussion about big blocks being narrower than GeoGrid and needing less excavation, well, it's really a cost neutral, because if you need 6 feet to put in a big block, you're generally looking to have about 6 feet for a no fines concrete Allen block mass as well. So it's pretty much cost neutral. So, all right, so let's just go over those ideas on the ready mix plant. So ready mix plants are generally, probably like many of us, we're reluctant to change. If you bring them the idea that we need some permeable, no fines concrete, they're going to immediately jump to their permeable pavement mix. And that is generally going to be a fairly expensive mix because it's got a lot of admixtures and so forth in it. So taking the time to steer them away and educate them on what no fines concrete is versus what permeable pavement is might take some time and a little effort to educate them. But um, and generally speaking, they possibly are going to charge too much because, frankly, they don't want to do it initially. But once they start using it, once they start doing it, then it's great. It's another tool in their toolbox to satisfy their clients. So don't get discouraged if a ready-mix plant gives you some grief initially, but they'll come around. Okay, so let's look at a project that's here in Minneapolis. It was built a couple of years back. This is out of AB Walls. You see the elevation view, the multiple cross sections. On the left-hand side is the wall in just GeoGrid. Well, there was a site constraint on property line, so they decided to go with the no fines concrete option, and that's a 3.5. The 4 foot happens to be the minimum grid length for a commercial project here, so that's why those are 4 foot grids. But 3.5 foot with that steeper slope, that 3-to-1 above, worked out very nicely. But so let's take a look. When the contractor put the numbers together, they were looking at GeoGrid and Big Block. So the GeoGrid application had 515 AB Classics, 86 caps, the grid, the piping, the rock, so forth. It came in at just under $10 a square foot. And if we take a look at the Big Block, when they started to research the big blocks, there were systems that were around the $8,000 range, and then a little more texture and color to them, and it came in at $10,000. So this came in, Big Blocks came in at about just under $25 a square foot. So right off the bat, you're seeing a pretty huge difference in material based on what product you're picking. So now if you jump back and take a look at the Classics, but then let's do no fines concrete. So it's a little more than grid, but not much more. So we're talking about a little less than $14. So there's your $10 a square foot in cost for the material. And then generally speaking, a lot of the contractors are going to use, twice the cost of the material is the labor. So again, you're going to have some savings there. But this is an actual project that was here, and thought we'd share those numbers with you as well. Okay, so I've been talking about no fines concrete being that extra tool in your toolbox, but Allen Block is giving you tools to help you be able to use it more efficiently and learn more about it. The first place to go is the allenblock.com. Go to our website, use the Google search bar, type in no fines concrete. You're going to find a number of different things, including some tech sheets, and these 2 tech sheets were created last year, just pulling together some information on how to design with no fines in our software, and then how to build with it. 2 very, very nice tech sheets that are easy to read, and you can learn a lot from them. And don't forget about us, the Allen Block Engineering Department, engineering@allenblock.com. We are here to help, so we can help with obviously the no fines, but really anything regards to an Allen Block wall or an Allen Block fence product, please reach out to us. Besides myself, I've got 5 other engineers here. You're really waiting to help out to make your job as easy as possible. So AB Walls, our last tool to talk about. This is a very powerful program. Now, of course, I'm biased. I've been using it for over 17 years as a member of the Allen Block staff, but you're going to find that it's extremely powerful for many different types of designs. So we'll talk specifically about no fines concrete today. Those of you that have seen it, great. If you haven't seen it, I pulled some slides together. Basically, after you've installed the program, you open it up, you have an opportunity to choose the region in which you're going to build the wall. Now, Allen Block is a worldwide company, so we have different areas that you can choose. By far, North America is our biggest market, but we have projects in New Zealand and Australia and Central America and Asia and Europe, all over. So you choose the producer you want from the region you want, and it will load all of the information about the block that that producer makes. On the next screen, you're going to choose what block you want. The AB Walls software obviously has all our products, so you have the AB collection, the Europa collection, the Fieldstone, as well as the Aztec collection, and then the specific blocks within each one of those collections. And now, even though you're designing a no fines wall, the program does want you to first pick a geogrid to use. So in this case, I've selected StrataGrid 200. And when you get to the cross-section screen, the program needs to know what kind of soils you're using. So infill, retained, and foundation soils are selectable, or you can choose to put whatever your site has. Then when you hit calculate, you're going to get your geogrid wall. So once you've got your geogrid wall, you can go to that design parameters button in the lower left corner, jump out to the next screen, choose the design options. In the design options window, you're going to have the opportunity to select yes for the question you want to design this section with no fines concrete. And then you can choose your 30, 45, or whatever number you want by clicking the toggles, or you can enter in a minimum depth that you're looking for in the box. If you want to see that Braun Intertek report on the testing, there is a view test report button there too that will bring up a PDF of that actual test you can read about. Once you do that, you come out, you hit the hide and hit the calculate. You're going to get now a cross section with no fines concrete. It's going to size it appropriately so that you have minimum sliding of 1.5 and overturning of 2. And you can see over here on the right-hand side that this case is over 1.5, so we're in good shape. And the geogrid area down below is blank because we don't have any internal calculations. So again, it's calculating like a gravity wall. So I want to show you this screen. So this particular wall is has a 45-degree curve in this area, and in this area here, like the wing walls that come out from the long flat area. It's about 10 feet tall. But in this particular corner, we were very close to the property line. So Allen Block software, the AB Walls program, allows you as the designer to design some sections as no fines and others as grid. So each one of these cross sections represented here, 1 through 4, could be designed differently from the one next to it. And in this case, we've got a no fines concrete section flanked by geogrid sections. And with that, again, I will thank you for being here, but I will also extend an invitation to reach out to us for tutorials on our software, questions on no fines, questions on anything. We're really here to help you guys be successful and make your projects run as smooth as possible. James, you typed a note. Thank you for that. The water cement ratio is somewhere between 45 and, if I misspoke, the 30%, 20 to 30% is the typical void ratio, so making it very porous. Joe's asked, how does the no fines compare to GeoGrid regarding lifespan of the wall? That's probably a good question. I don't know if there's been technical reports done on it, but like I said, we've got walls that are 20 plus years old in Australia that are continuing to working just fine today as they did then. We are talking about a solidified concrete mass, and the concrete should stay solidified for its life, and the GeoGrid obviously has proven to be very functional for many years. NCMA talks about a 75-year life span, but I'm sure there's more. All right. Well, it looks like another one is typing in. Apologize, we don't have the ability to have voice. We are just doing the texting. John is asking if filter fabric is needed between the no-fines concrete and the retained soil, and generally speaking, we would say no. What about clogging the no-fine grains? I suppose it's possible, but no. Generally speaking, we do not promote it. I don't know of other manufacturers that would promote it when they're using it either. If you are talking about a water application, no-fines concrete has been used occasionally on that. Typically, water application is going to be a washed wall rock with a grid, and then you're going to have an embankment protection fabric behind it. So as the water rises and falls, it doesn't draw in material from the retained soil into the washed rock. But no, we don't typically see or promote the filter fabric behind the no-fines concrete. All right. Well, with that, it looks like, oh, I got one more question came in here. Let's see. Okay, Josh is asking if you're placing no-fines concrete, an elm block wall, and no-fines concrete in front of a stable railroad tie wall. Can the depth be less than 30? And I'd say yes. So the stable railroad tie wall is still functioning, and now you're going to put a no-fines concrete mass in front of it. So maybe you're only talking about a 1 foot to 1.5 foot of material in front or between the two walls to again promote drainage and keep the railroad ties as dry as possible. But yeah, no, the railroad ties are still functioning. The wall, the extended wall, will just increase the face of that retaining structure, and it'll do a great job. And I should have mentioned that in the presentation. We're facing deteriorating wood walls. It's a great use for it as well. Thanks, Josh, for asking that question. Okay, well, hey, with that, I appreciate everybody being part of it. If there are additional questions, feel free to reply to the email I'll send you here a little bit, and I'd be glad to answer them then. And I, again, appreciate the time. Have a great rest of the day, and please reach out to us with any questions. We're here to help.